Lisa Nelson, and I will be teaching about FSH muscular dystrophy. So I have an activity that I'm going to have you guys try, and this is to represent what it's like to have FSHD. One of the most common and most known symptoms of FSHD is them not being able to lift their arms above their head for more than a few seconds, or even lift their arms at all. And so to demonstrate this, I have these two different elastic bands, and this one, the TheraBand, is going to represent mild muscle weakness, like at the beginning of symptoms, and then this one is going to represent more severe muscle weakness. And so does anybody want to try it? So that it's on both sides like this, and then you're just going to lift your arms. It represents how, the muscle weakness, how just lifting your arms by themselves, and then going to that, it shows the weakness that they're starting to form. And then when you go to this one, and you can, if you want to explain like what it feels like, that's fine. And so this one will just show the more severe muscle weakness that they get as a. Pharmaceutical companies are starting to develop treatments to boost muscle growth, and it doesn't deal with the deterioration of muscles, but it does a lot to minimize the complications and maximize the function of the muscles that you still have.
So say if like two parents have a kid that has FSHD, could they possibly have another kid? Like say they didn't have like the genetic, like you're saying like sporadic FSHD.
So neither of them have FSHD?
Yeah. So like a sporadic FSHD, like when their kid would have?
Yeah, so neither of the parents have the disease, but their child does.
If they had like a second child, would they also have sporadic FSHD, or is it?
It's unlikely, but it is possible. We have a family friend who, my dad works with his dad, and neither of them have FSH, but their son does. And then they have 3 other kids who all of them don't have FSH.
Can a parent like be a carrier and they have it but not like actually have it?
Well, it's a dominant trait, so if they have the gene for it, or if they have the gene for it, then they will have the disease. And so for FSHD1, it was found that the cause is due to a loosening of the DNA structure due to the lack of repeats on chromosome 4. FSHD2 is caused also by the loosening of the DNA structure, but because of a decrease in molecular bonds between the DNA strands. Both of these causes create the DUX4 gene to be expressed, and normally the DUX4 gene is not expressed in muscle cells, and so that is why it is toxic and causes the muscle deterioration. When I say repeats, I'm referring to what's called the D4Z4 chain, and that's what this is, and it can have up to 200 repeats of the DUX4 gene. In FSHD, there are less than 10, and so that's what causes the loosening of the DNA structure, because there are less repeats. In FSHD2, it was found that another gene from chromosome 18 was the main cause of the loosening of the DNA, and it's called the SMCHD1, which is, they refer to it as the smooch gene. It's responsible for the decrease in the molecular bonds. What's odd about this disease is that the DUX4 gene is not a mutation, which is really unusual for genetic disorders. So the DUX4 gene is usually not expressed because it is repetitive, and because the gene repeats multiple times, it creates the D4Z4 chain. It's like a zipper, so the repeats allow the structure of the DNA to be more tightly bound, like a zipper, and so it when it's folded, the DUX4 cannot be expressed. The DUX4 gene is normally found in stem cells, and so the problem arises when it is expressed in mature muscle cells. When the DUX4 gene is being expressed, it can cause different problems that relate to the muscle deterioration.
What's the difference between FSHD1 and FSHD2?
FSHD1 has to do with the DUX4 gene being, the repeats in the DUX4 gene and the D4, the D4Z4 chain having repeats being less than 10, and then FSHD2 is the gene, the smoosh gene from chromosome 18 that affects the molecular bonds of the DNA structure. So there is a lot of research going on for this disease, and I'm going to explain 4 different research projects that are being funded by the Friends of FSH Research. So the first one is by Dr. Maura Parker of the University of Washington. She is studying mice and using them to study the progression of FSHD. This will allow the study of FSH to be done without the need of people who have the disease and having them go through different procedures that could be painful for them. Another one, Dr. Barbara D. Page of the Fred Hutchinson Cancer Research Center. She is using model organisms to discover new therapies, and one of the benefits of this is that it will allow researchers to learn more about the disease. Next one is Dr. Eric Wagner and graduate student Natoya Pert of the University of Texas Medical School. They are working on finding possible antagonists against FSHD to inhibit the DUX4 production and lessen and even prevent symptoms of the disease. And the last one, Dr. Daniel G. Miller of the University of Washington and Dr. Galina Filippova of the Fred Hutchinson Cancer Research Center are working, and this one was one of the research projects that really confused me. They're working on chromatin structure modification for possible treatments, and one thing that they're doing is targeting the modified chromatic structures and reducing DUX4 transcript levels and this can be used to develop something that can what's called silence the gene, and that's basically inhibiting or suppressing its functions. Okay, so now I'm gonna have an online quiz. So there's 14 questions. First question, what is FSHD? And there's 30 seconds for each question. So, what is the cause for FSHD1? Be careful with this answer.
Oh, I was too slow.
What is the cause for FSHD2? What is D4Z4? This is the last question. Modification of chromatin structure of D4Z4 is important for what?